integrating factor. So here, what is integrating factor? Now we are discussing exact differential equation which is in the form m dx plus n dy equal to 0, in which dou m by dou y equal to dou n by dou x. But sometimes this dou m by dou y may not be equal to dou n by dou x, that is dou m by dou y not equal to dou n by dou x. Then given dE is not exact differential equation. In that case, to reduce the given non-exact to exact differential equation, we are going to multiply with a suitable function. If you multiply with that function, that non-exact dE becomes exact. The function which makes the non-exact dE as exact, that function is called integrating factor. So integrating factor generally we use whenever dou m by dou y not equal to dou n by dou x. There we think about integrating factor. So here the case is if m dx plus n dy equal to 0 is not exact. When it is not exact dA, then by multiplying a suitable function u of xy which is not equal to 0, the dE m dx plus n dy equal to 0 can be reduced to exact. The dE is not exact initially. We are going to multiply with a suitable function u of xy which is not 0. Then this dE becomes exact now. The function which we are using to make non-exact as exact, that function is called integrating factor. Here that function is this one. So here u of xy is called integrating factor. So now we are going to solve some problems in exact dA in which dou m by dou y may not be equal to dou n by dou x. That means the given dE is not exact. Then what we are going to do to make dou m by dou y equal to dou n by dou x, we are going to multiply with a suitable function that is called integrating factor. There are so many types of integrating factors. In that few we can easily identify. So this is one integrating factor. We represent integrating factor like I dot m. Integrating factor. There are so many integrating factors. In that few we can easily identify. 1 by mx plus ny. This one is one integrating factor. So you know what is integrating factor. If you multiply given dE with this, that becomes exact. This we use when the dE is homogeneous. When the dE is homogeneous and non-exact. Homogeneous and non-exact. Homogeneous means, I said, in given dE, if m and n, in m and n, every term has same degree. X square plus y square dx minus 2xy dy. In that problem, each term has same degree too. So like this I am saying. X square plus y square, here you may have dx, here 2xy dy. If you observe, the degree of xy is 2, degree of y square is 2, degree of x square is 2. So these type of problems when you are doing, if dou m by dou y equal to dou n by dou x, then no problem. You can do the problem directly. Whenever dou m by dou y not equal to dou n by dou x, you need to multiply with a suitable function, integrating factor. That one is this one. Another one, 1 by mx minus ny. So this one we use as integrating factor if given DE is in the form, like this, y into f of xy dx plus x into g of xy dy equal to 0. If you have this form, we go for this one. Like this, we have so many integrating factors, few we are discussing now. So this one is when D is homogeneous, this one is when D is in this form. Like this, we are going to discuss 3 to 4 integrating factors when we get this thought, integrating factor thought. Whenever dou m by dou y not equal to dou n by dou x. If dou m by dou y equal to dou n by dou x, you won't think about integrating factor. Directly you will write general solution, that is integral m dx plus integral terms not containing x in n dy plus c. But whenever dou m by dou y not equal to dou n by dou x, then you need to think about integrating factor. You need to multiply given dE with a suitable function to make it exact. There we are going to think about integrating factors. So that type of problems we are going to discuss on this. Okay, this is an important topic, reducing non-exact as exact for essay type. Exact is directly for short answer. Okay. Solve x square y dx minus x cube plus y cube dy equal to 0. So, if you see this dA, you can easily identify the dE is in mdx plus ndy form. So, immediately after identifying that is in mdx plus ndy form, simply write what is m and what is n. So, m equal to x square y, n equal to minus x cube minus y cube, minus into plus minus. So now coming to dou m by dou y, differentiate partially with respect to y. Differentiate y terms only, don't differentiate x, keep x as constant. So x square constant, differentiation of y is 1. So that is x square. Dou n by dou x, differentiate x terms only, don't differentiate y, keep y as constant. So this becomes 0. Differentiation of x cube 3x square. Now see, dou m by dou y not equal to dou n by dou x. Dou m by dou y not equal to dou n by dou x. What it means? Given dE is not exact. Given dE is not an exact dE. So now what happens? We need to multiply given dE with a suitable function so that it is reduced to exact differential equation. For that we need to think about integrating factor. There are so many integrating factors depending on the nature of given dE, the form of given dE, we select the suitable integrating factor. Now if you observe the given dE, in given dE you have x square y. The degree of x square y is when two terms are in product, to find degree add exponents. Y power you are having 1. 2 plus 1, 3. So degree of x square y is 3. Degree of x cube is 3. Degree of y cube is 3. So all the terms have same degree, equal degree. Then we say that the dE is homogeneous. And given dE is homogeneous. When given dE is homogeneous and non-exact, then the suitable integrating factor is 1 by mx plus my. This is suitable integrating factor. So first find out where mx plus my should not be equal to 0. So find out what is mx plus my. Are you getting what I am saying? Multiply m with x. Multiply m with x. X into x square by x into x square. X cube y minus. Because you have minus here. Minus into plus minus. Multiply n with y. X cube into y. X cube y minus y cube into y. Y to the power of 4. See here. plus x cube y minus x cube y get cancelled. So what is left over term? Minus y to the power of 4, which is not equal to 0. So now the integrating factor is 1 by mx plus my. 1 by minus y to the power of 4 is integrating factor. I written if here itself. This is integrating factor. So integrating factor means that is a suitable function which makes given non-exact dE as exact if you multiply. So for that what we are doing, we are going to multiply given non-exact dE with this. Multiplying given dE with 1 by minus y to the power of 4. Multiply complete dE with this. So if you multiply x square y by minus y to the power of 4, that minus becomes plus x cube plus y cube by, otherwise keep minus here. Next step we will make plus. Here dx, here dy. Okay, now take this term as it is like this. You can cancel one y, right? If you cancel, what you will have? Minus x square by y cube dx. Minus into minus plus x cube plus y cube by y to the power of 4 dy equal to 0. Okay, any doubts you may express here. Multiplying with minus 1 by y power 4 given dE, you got like this. Now the simplified term of this one I written there. After multiplying given dE with integrating factor, you will get a new differential equation which will be in the form m1 dx plus n1 dy. Let given dE is in this form. Let the dE we are assuming as m1 dx plus n1 dy, n1 dy. Now take m1. What is m1? Minus x squared by y cube, and take n1 x cube plus y cube by y to the power of 4. Actually, if you find a suitable integrating factor, that non-exact becomes exact. No need to check dou m1 by dou y equal to dou n1 by dou x. But I am proving here our integrating factor is correct and suitable. For that I am finding. But if it is homogeneous non-exact, mx plus ny is correct integrating factor. No need to check. But we are checking here once whether our integrating factor is correct or wrong. Dou m1 by dou y. Differentiate m1 with respect to y, keeping x constant. Differentiation of 1 by y cube minus 3 by y to the power of 4. Differentiation of 1 by y cube minus 3 by y to the power of 4. Then what happens? Minus into minus plus 3x square by y to the power of 4. Differentiation of 1 by y cube minus 3 by y to the power of 4. You will get minus 3 in numerator, this becomes plus, denominator you will get y to the power of 4. Now, dou n1 by dou x, that means differentiate x terms only, don't differentiate y, keep y as constant. Differentiation of x cube, differentiation of x cube is 3x square by y to the power of 4. This y cube is constant, differentiation of constant is 0 because that is separator. Now see these two, dou m1 by dou y and dou n1 by dou x. These two are equal. Dou m1 by dou y equal to dou n1 by dou x. Clear? Any doubts you may express. Here, dou m1 by dou y equal to dou n1 by dou x. Therefore, the dE is exact. When D is exact, you need to find general solution like this. General solution, integral m1 dx, keep y constant, plus integral terms free from x in n dy plus c equal to 0. Integral m1, what is m1? Minus x squared by y cube. So while integrating, keep y constant. Terms free from x. Terms do not contain x in n. So here m1, n1. n1, if you observe very clearly, there are two terms. The two terms are these: x cube by y to the power of 4 plus y cube by y to the power of 4 1 by y. If we split, then you can find the terms free from x. Terms do not contain x in n. We have two terms in n, n1. In that, we need to find out the term do not contain x. In first term we have x. In second term we don't have x. That term we need to write here. 1 by y dy. So now integral x square is x cube by 3, x cube by 3 y cube, plus integral 1 by y is log y plus c equal to 0. This is the general solution of given non-exact dE, the dE which can be reducible to exact. The dE which can be reducible, that means which is not actually exact, which can be reducible to exact by multiplying with suitable integrating factor. Are you clear? Solve x into x square plus y square plus 2 dx plus x into 2 minus 2x square y square dy equal to 0. To solve this, first write m and n. This is m, this is n, you know, m dx plus n dy form. So now, for writing m, multiply this term with y, that is exact m, y into x square y cube plus 2y. n is multiply with x, 2x minus 2x cube y square. Now find out dou m by dou y and dou n by dou x. Dou capital M by dou y. Differentiate y terms only, don't differentiate x. Differentiation of y cube, 3y square. 3y square, that is 3x square y square, plus differentiation of y, 1. Dou n by dou x. Dou n by dou x. Differentiate with respect to x. Differentiation of x is 1. Differentiation of x cube is 3x square. Differentiation of x cube 3x square. So that means 3 2s are 6. X square y square. Now if you observe, you can easily identify dou m by dou y not equal to dou n by dou x. Therefore, given d is not exact. Given d is not exact d. Whenever given d is not exact, then think about integrating factors. If m and n in every term in m and n are equal degree, that is homogeneous. But here the degree of this term is 5, degree of this term is 1. So this is not homogeneous. Then think about whether given d is in the form, given d is in the form y into f of xy dx plus x into g of xy dy equal to 0. So see, yes, it is exactly in that form. Y into f of xy dx, x into g of xy dy. When the d is in that form, then the integrating factor is 1 by mx minus ny. 1 by mx minus ny, where mx minus ny not equal to 0. Now find out mx minus my. Multiply m with x, n with y. Multiply m with x, multiply this one with x. X into x square, x cube y cube plus 2xy minus n with y and multiply with minus n with y minus 2xy minus into minus plus 2x cube y cube. So see here, plus 2xy minus 2xy get cancelled. So 1x cube y cube, here 2x cube y cube, totally you have 3x cube y cube, which is not equal to 0. Then the integrating factor is 1 by mx minus my, 1 by 3x cube y cube. So this is the integrating factor. Now multiply given dE with integrating factor to make it exact. Multiplying given dE, multiplying given dE with integrating factor. So that means 1 by 3x cube by cube. If you multiply given dE with integrating factor, what happens? If you multiply with this term, so x square y cube by 3x cube y cube, every term I am multiplying, plus 2y by 3x cube y cube dx plus 2x by 3x cube y cube minus 2x cube y square by 3x cube y cube dy equal to 0. So multiplying each term with this term, that means dividing every term with 3x cube y cube. If you divide, what happens? Here x square x cube y cube get cancelled, you will have 1 by 3x. Coming to the second term, 2 by, here y cube, here y, 3x cube y square. Coming to the next term, 1x get cancelled, 2 by 3x square y cube minus x cube cancel, y only will have 3 by x cube cancel, y square y cube y, dy equal to 0, which is in the form m1 dx plus n1 dy. Now write m1 and n1. m1 is 1 by 3x plus 2 by 3x cube y square. n1 is 2 by 3x square y cube minus 2 by 3 by 2 by 3 by. If you want, you can check do m1 by do y, do n1 by do x. You will get definitely equal. Otherwise, you can write directly do m1 by do y equal to do n1 by do x if you are confident enough on your integrating factor. Just I am checking whether do m1 by do y is equal to do m1 by do x. No need to check, you can write do m1 by do y equal to do n1 by do x, no problem, if you are confident. So I am proving that should be equal. Do m1 by do y. So if you have y, differentiate. If you don't have y, keep that one as constant. Differentiation of constant 0. This term becomes 0. Now coming to here, differentiation of 1 by x cube minus 3 by x power 4. Differentiation of 1 by x cube minus 3 by x power 4. You will get in numerator minus 3, minus 3 2 just 6. 3 x power 4 y square, which can be written like this, minus 2 by x power 4 y square, 3 2 0. So coming to here, do n1 by do x. Here also differentiation of x, differentiate with respect to x. If you differentiate with respect to x, differentiation of 1 by x square minus 2 by x cube, that means minus 4 by 3x cube y cube. So with respect to x, sorry, here with respect to y, right? With respect to y means, sorry, with respect to y means differentiate y term only. If you differentiate y term, you have y square, 1 by y square. Differentiation of 1 by y square minus 2 by y cube. That means here also you will get minus 4 by 3x cube y cube. You will get minus 2 in numerator, power will be increased by 1. These two are equal, right? Minus 4 by 3x cube y cube, minus 4 by 3x cube y cube. That means dou m1 by dou y equal to dou n1 by dou x. Given d is, that is, this d is exact. D is exact. When d is exact, we write general solution like this. Integral m1 dx, new differential equation, we call dx coefficient as m1. Integral m1 dx, keeping y constant, plus integral terms free from x in n1 dy plus c equal to 0. Integral m1 we have 1 by 3x plus 2 by 3x cube y square dx. n1, in n1 terms do not contain x. Terms do not contain x is only one term, that is minus 2 by 3y dy. Now integrate, integral 1 by x we know, integral 1 by x is log x. So 1 by 3 log x plus y constant 2 by 3y square. Integral 1 by x cube, integral 1 by x cube we have. Integral 1 by x cube means you will get x power minus 3 plus 1 by minus 3 plus 1. That means minus 2 by x power 4. Minus 1 by x square. Minus 3 plus 1. Minus 2. Minus 2 by x square. That means you will have minus 2 by x to the power of 4. Sorry, x square. Minus 3 plus 1. Minus 3 plus 1. Minus 2. So now, next coming to here, minus 2 by 3, integral 1 by y, log y, plus c equal to 0. Integral 1 by x log x, integral 1 by y log y. Integral 1 by x cube we are having in the second term. Integral 1 by x cube is minus 2 by x square. Minus 2 by x square. X square. So finally we will have minus 4 by 3x square y square. So this is the general solution of given non-exact dA which can be reducible to exact by multiplying with a suitable integrating factor mx minus ny, that is 1 by mx minus ny. Any doubts you may express anywhere. Solve 2xy dy minus of x square plus y square plus 1 dx. So if you observe, this is in this form. M dy, m dx plus n dy form. M dx, n dy. Dy coefficient is n. M dx plus n dy. 2xy dy minus of x square plus y square plus 1 dx. Now, note down what is m. M is minus x square minus y square minus 1. N is 2xy. M dx plus n dy. Dx coefficient is m. Now find out dou m by dou y. Dou m by dou y is with respect to y, differentiation of y square to y. You don't have y here. No need to differentiate. If you differentiate also, differentiation of constant 0. Dou n by dou x. With respect to x, differentiation of x1, you will get 2y. Differentiation of x1. So now, these two are not equal. Dou m by dou y not equal to dou n by dou x. So, D is not exact. We need to think about integrating factors. There are so many integrating factors. If all the terms have same degree, we use 1. If you can take y common here, x common here, then we use another. But here all the terms do not have same degree. X square, y square same degree, but one degree is 0. You cannot take y common here. Then we cannot think about two integrating factors, 1 by mx plus ny, 1 by mx minus ny. 1 by mx plus ny we use when all the terms have same degree. 1 by mx minus ny we use when we can take here y common, x common. In that case, think about two integrating factors, these two, 1 by n into dou m by dou y minus dou n by dou x. What we will get? 1 by n into dou m by dou y minus dou n by dou x. What is n? 1 by 2xy dou m by dou y minus 2y dou n by dou x minus 2y. Minus 2y minus 2y minus 4y by 2xy. y cancel, 2 1s are 2 2s are. Minus 2 by x, which is function of x. If 1 by n into dou m by dou y minus dou n by dou x, if you get function of x are constant, then we prefer this one as integrating factor. If you won't get this one as function of x are constant, then 1 by m into dou n by dou x minus dou m by dou y we will do. 1 by m. When you won't get this one as function of x. So now we have, this is a function of x. So the integrating factor will be this one, e power integral f of x dx. F of x is that one, e power integral minus 2 by x dx, e power integral 1 by x log x. So this can be written like this, e power log x power minus 2, because e power log f of x is f of x. E power log f of x is f of x, e log. So x power minus 2 can be written as 1 by x square. Here we use this one, e power log f of x is f of x. Using this, we got that one. So now integrating factor is this one. Now multiply given dE, multiply given dE with 1 by x square to reduce it to exact form. So if you multiply given dE with 1 by x square, what you will get? You will see, multiply this dE with 1 by x square, 2xy by x square dy minus x square plus y square plus 1 by x square dx equal to 0. If you multiply with 1 by x square, that means dividing each term with x square. What you will get here? 2y by x you will get. If you simplify this one, x square by x square 1 plus y square by x square plus 1 by x square dx. Now m1 is minus 1 minus y square by x square minus 1 by x square. n1 is 2y by x. Now if you want, you can check dou m1 by dou y is equal to dou n1 by dou x or not. That should be equal. We will prove dou m1 by dou y, differentiate with respect to y. That means differentiate y terms only. Differentiation of y square 2y minus 2y by x square. Dou n1 by dou x, differentiate with respect to x. Differentiation of 1 by x minus 1 by x square. Differentiation of 1 by x minus 1 by x square. These two are equal. So dou m1 by dou y equal to dou n1 by dou x. D is exact. When D is exact, the general solution for that D is integral m1 dx, keep y as constant, plus integral terms free from x in n dy plus c. So that is m1, complete m1 term, minus 1 minus y square by x square minus 1 by x square dx, plus integral terms free from x in n. That means terms do not contain x in n. Terms do not contain x in n, we don't have, because only one term we are having in n1. Only one term we are having in n1. in that term you have x, so the terms do not contain x in n1, we don't have, that is 0. Now integral 1 dx x, integral 1 by x square minus 1 by x, integral 1 by x square minus 1 by x, so y square by x plus 1 by x plus c equal to 0. So this is the general solution of given exact differential equation. Given non-exact d which can be reducible to exact. Solve x y cube plus y dx plus 2 into x square y square plus x plus y to the power of 4 dy equal to 0. So this is exactly in this form, m dx plus n dy form. So to solve this, first write what is m and n. X y cube plus y, n equal to 2 into x square y square plus x plus y to the power of 4. Find out dou m by dou y and dou n by dou x. Dou m by dou y. Differentiate partially with respect to y. Differentiation of y cube 3y square. So 3xy square, differentiation of y1. Dou n by dou x. Dou n by dou x, differentiation with respect to x. Differentiation of x square 2xy square, differentiation of x1, this will be constant 0. Differentiation of x is 1, differentiation of x square 2x. Differentiation of y cube is 3y square, differentiation of y is 1. Now, these two are not equal. If you want, you can compare. If you multiply 4xy square plus 2 only you will get. These two are not equal, right? Then dou m by dou y not equal to dou n by dou x. So d is not exact. When differential equation is not exact, then you need to think about integrating factors. If all the terms have same degree, then we use 1 by mx plus ny. If you can take y common here, x common here, then we use 1 by mx minus ny. We don't have all the terms of same degree. We cannot take here x common. Here we can take y common. Then 1 by mx plus ny, 1 by mx minus ny are not suitable. Then think about these integrating factors. Find out this value. 1 by m into dou n by dou x minus dou m by dou y. What is m? 1 by xy cube plus y into dou n by dou x we are having 4xy square plus 2 minus dou n by dou y is this one, 3xy square minus 1. So see here, you can take y common here, xy square plus 1. Here, 4xy square minus 3xy square. If you subtract 3 from 4, you will get 1, 1xy square, 2 minus 1. 2 minus 1 is 1. So these two get cancelled. Integrating factor is 1 by y. So not integrating factor. 1 by m into dou n by dou x minus dou n by dou y is 1 by y, which is function of single variable y. Function of single variable y. If you have like this, if this value is function of y alone, then this is suitable. We can use this one as integrating factor. E power integral, this one as integrating factor. If it is function of xy, we think about 1 by n, dou n by dou y minus dou n by dou x. If that one is function of x, then we use that. Because this one we got function of y alone, we can use this one as integrating factor. E power integral f of y dy. So f of y is that one. Integral 1 by y dy, e power log y. So we know e power log f of x. E power log f of x is f of x. So y you will get. Integrating factor is y. So multiply given dE. Multiply given dE with y. What you will get? If you multiply given dE with y, this one we are going to multiply with y. So x y to the power of 4 plus y square dx plus 2 into x square y cube plus xy plus y to the power of 5 dy equal to 0. Now treat this one is in the form m1 and n1 dx. Find out what is m1 and n1. So m1 equal to xy to the power of 4 plus y square, n1 equal to 2x square y cube plus 2xy plus 2y to the power of 5. So now find out dou m1 by dou y. Differentiate with respect to y. Differentiation of y power 4y cube, 4xy cube, differentiation of y square 2y. Dou n1 by dou x with respect to x. So differentiation of x square to x, 2 2s are 4, xy cube. Here differentiation of x is 1, 2y. Clear? Here you don't have x terms. Keep that one as constant. Differentiation of constant is 0. Now observe, these two are equal. 4xy cube plus 2y, 4xy cube plus 2y. What it means? Dou m1 by dou y equal to dou n1 by dou x. So d is exact. When d is exact, the formula to evaluate general solution is integral m1 dx keeping y constant plus integral terms free from x in n dy plus c equal to 0. Integral m1. So write m1 term as it is x y to the power of 4 plus y square dx keeping y constant plus integral terms free from x in n1. In n1, find out the terms which do not contain x. We have 3 terms. In one term we don't have x in this term. So note down that. Terms do not contain x in n1 dy. Now keeping y constant, integrate y power 4 constant, integral x square by 2. Y square constant, integral 1 dx x plus 2 into integral y to the power of 5, y to the power of 6 by 6 plus c. Here if you want you can cancel with 2. So that is the general solution. Integral y power 5, y power 6 by 6. That is general solution of given differential equation.